So guys, any new beginner means anybody who is trying to write a multi-threaded application for the first time, or anybody who don't have much experiences in writing thread-safe multi-threaded applications would do the following. So for example, you have a linked list in your application. As I said, it could be any data structure. For demonstration purpose, we have assumed that our data structure is linked list. So this is the linked list of students, and we would represent this linked list with the following structure. All right. Now you can see that we have a mutex member, and this mutex member is defined at the level of linked list. All right. So it means that this particular mutex is a mutex of this entire linked list. So it means that any thread which will lock this particular mutex would get an access on this entire linked list, and then that particular thread can perform any operation on this entire linked list. All right. So if before invoking any of the CRUD APIs, that is whether the thread wants to perform create operation, delete operation, read operation, or any operation on the linked list, if the thread lock the entire linked list by invoking the pthread lock API on this mutex, then thread is free to perform any operation on this linked list. All right. So it simply means that our program is absolutely thread safe. If the thread T1 performs an operation on this linked list after locking the mutex, then any other thread in the system who wishes to perform an operation on this linked list would be blocked. All right, because it is the thread T1 which already has that mutex. So this is pretty much very simple thing to do. All right, our application would be absolutely thread safe. But the downside of this approach is that we are locking the entire linked list. All right, it will going to degrade the application performance drastically. It will going to create very heavy contention between the threads. Contention means threads blocking each other. So for example, let's say thread T1 wants to perform read operation on the student whose roll number is 2, whereas the thread T2 wants to perform again read operation on the student whose roll number is 3. And be noted that whenever any thread wants to perform any type of operation on the linked list, the thread will lock this mutex. And when the thread is done with its operation on the linked list, then it will unlock this mutex. So in this example, I don't see any reason that why thread T1 should block thread T2, or why the thread T2 should block thread T1. They are performing operations on the data structures, but those operations are non-conflicting with each other. We already know that read operation do not conflict with each other. So if we allow both the threads T1 and T2 to execute simultaneously without having to lock this mutex, then our application state remains consistent. We do not introduce any anomaly, data structure corruption, race condition, or anything which wrong thread synchronization introduce in the application. Here both the threads T1 and T2 are not only performing read operations, but also they are performing the operations on different student objects. So I don't see any reason that why thread T1 should block thread T2 or why thread T2 should block thread T1. They should be allowed to execute simultaneously on different processors of your system. All right. And still at the end of the day, your program would still be in consistent state. So here locking the entire data structure is heavily discouraged. If you lock the entire data structure unnecessarily, one of the threads would be blocked while the other thread is enjoying an access to the data structure. So it is analogous to like locking down the entire city when there is only one COVID case in the city. All right. This is kind of an example where one thread is accessing or performing some operation on some node of the linked list, whereas there is some other thread which is interested in performing an operation on some other node of the linked list, not necessarily the node number 2, but unnecessarily we are making the thread T2 to stay blocked. So critical section should be as minimum as possible if you want to extract out maximum performance out of your application, provided that your application is multi-threaded. Thread must block each other only when it is absolutely necessary to do so. Even if we discuss some other example, let's say the thread T1 performs a read operation on the student whose roll number is 2, whereas the thread T2 performs a write operation on the student whose roll number is 3. In this case also, I don't see any reason that why the thread T1 should block the thread T2 from getting an access to the linked list, and why the thread T2 should block thread T1 from getting an access to the linked list. Both the threads can very well execute in parallel on different processors of the system without introducing any error or anomalies in the program. So locking the linked list level mutex by a thread is highly discouraged. All right. Of course, it will guarantee accurate thread safe operations being performed on the linked list, but the performance of the application would be very poor. So let us discuss in the next slide that what exactly we are trying to achieve by saying that we will going to implement CRUD operations which are not only thread safe but also highly concurrent.